Statistically significant is the term given for when the observations in a statistical experiment are unlikely to have occurred by chance. The most commonly used statistically significant level is 0.05 or 5%. The probability of an observed result occurring by chance, or if the probability of an observed result occurring by chance is 0.05 or less, the difference is called statistically significant at the 0.05 level. So important to remember at this time is that the unusual definition defined by the empirical rule was anything outside of 2 standard deviations from the mean. So if we remember what that looked like when we had a normal curve with the mean in the middle, and then we went out 2 standard deviations to the right and to the left, we would say that 95% of observations fall in there, with only 5% landing outside of there. So unusual was when there were that 5% value in the tails. So that's where this sort of comes from, is that if you land, you're expecting to be here. You expect to hit that center value, the mean. On average, this is what happens. So that's what we expect to happen. So whenever you're saying that an observed result has a 0.05% or less chance of happening, that means it's happening out here somewhere in these tails where it's only 0.05% likely to land out in that area. Okay, so that is unusual. We are surprised when things happen, when things fall that far away from what we expect. Now, other significant levels can be used. Sometimes they use 0.1, sometimes 0.01, and others, but those are I would say, the next 2 common statistically significant levels. But what's important to remember is that the smaller the significance level is used, then the greater of a significance that you found. Right? If you use a smaller significance level, it means you're getting farther and farther out on these tails. So the smaller significance level that you've got, really the greater of a significance you've found. Like there's really evidence now that something is going on that's very interesting. I'm so far away from what I expect that I really think that something interesting is happening. So let's just practice using our wording. It says a poll was taken at a college to determine how favorable lowering the voting age to 16 is. Of 256 seniors surveyed, 32% of them were in favor. Of 278 freshmen surveyed, 46% of them were in favor. So when calculated, the probability of the difference in percentages being the result of chance is less than 0.05. Interpret the result of this calculation. So we don't know how to calculate that yet. We haven't been shown that, but you will learn how to do that. But they've already calculated it and said that the probability of the difference in these 2 values being totally due to chance is less than 0.05. So what we have at this point is that the results that were found are statistically significant at the 0.05 level. That's what we could say. So it matters what level you're talking about. Whenever you do your write-ups, you want to make sure you reiterate what level the significance was made at. What this tells us is that there is a 0.05 or less, so a 5% chance or less, that the difference in these percents is due to chance. So what this tells us then, if there's less than 5% or less chance that the difference we're seeing here is due to total chance, what we now know is that we are confident, that's how we usually say it, we are confident that the two grade levels really do feel differently about this topic. Because you could do one single survey and get slightly different percentages, but maybe those percentages are not enough to say like overall all seniors and all freshmen have very different opinions about this. But we've got such a different percentage, like 32% is so far from 46%. They're so far away from each other that it's enough to say, no, they really do feel differently. If you go ask random seniors and random freshmen, you are likely to get these very different percentages over and over again. So that's all three of those statements are different statements that we could say with this information. Okay, so finally, moving on, the last kind of topic in this section is the idea of random variables and distributions. So a random variable, capital X, is what's used for those, describes the outcomes of a statistical experiment, and it can take on a set of different possible values. Then you have what's called a frequency distribution, which is the number of times each possible outcome occurs within a study or an experiment. So frequencies are just the numbers. And then there are probability distributions, which are the percentages or the probabilities of each possible outcome of a discrete random variable. And these always have to add up to 1 or 100%. So the two properties of a probability distribution boil down to each probability must be a value between 0 and 1, because we already know that about probabilities, and that the sum of all of the probabilities has to equal 1. So you may get presented information in a table and asked whether this could even be a probability distribution or not. So you're looking for any things that may violate either of these two properties. So I see X as the random variable here, and that X could take on the values 1, 2, 3, and 4. So those are all the possible outcomes of some experiment. So maybe you're drawing cards out of a deck, but the only numbers on these cards are 1, 2, 3, and 4. Or you're spinning a spinner that has 4 slices to it. Okay, so those are the only 4 outcomes that we could get. And then the second row here tells us all of the different probabilities. So it tells me that the probability of, let's say, spinning a 1 is 0.2. Nothing seems wrong there. Okay, so the 1 chunk holds up 20% of the space, so that seems fine. But then notice what it tells me next. The probability of spinning a 2 is negative 0.3. You cannot have a probability of negative. So that is no negatives. That is a red flag. I cannot have negative probabilities. And then it tells me that the probability of spinning or rolling, let's say, a 3 is 1.4. Can I have over a 100% probability? No, I cannot. So that's another eh. So I can't have any probabilities over 1. Now, the probability of rolling or spinning a 4 being 50% would be technically fine. But I've already blown it with these other two. And also, even if you don't see anything glaring like this, like maybe you don't see any negative probabilities, you don't see any that are over 1, those are the easiest ones to pick out. The other thing that you have to check is this second property here, which is they have to all add up to 1. So 0.2 plus negative 0.3 plus 1.4 plus 0.5 equals 2.8. It doesn't equal 1. So here we've basically failed in every possible way. We have probabilities shown individually that are not between 0 and 1. And additionally, the sum of all the probabilities is not 1. But you only have to fail some part of that in order to not have a true probability distribution. But when you know those properties, it can help you, because let's say I knew the probability of rolling a 1 and a 2 and a 3, I could then fill in the probability of rolling a 4, because I would know that it was whatever was left over needed to make them add up to 1, let's say, if everything was as it should be. So we need to be able to recognize when something is not actually a probability distribution, but also if we're told that it is a probability distribution, we can use those properties to further answer more questions.